Earlier in the course, I talked about the load balancer infrastructure pattern. And the purpose of this pattern was to provide a way to distribute requests that were being made by customers to services that can respond to those requests. For example, you might have customers that are accessing a web server or website, and that website is hosted on a fleet of EC2 instances, which are configured as web servers. You need some infrastructure component that will take those incoming requests from customers and route those requests to a web server that can respond back to the customer. AWS provides this load balancing pattern using a service called the Elastic Load Balancing Service, otherwise known as ELBs. ELBs provide that endpoint that external users can access. And the ELB will take a request from an external user and redirect that request to an EC2 instance that you have configured. The ELB is pretty smart. It will monitor the health of your EC2 instances, and it will only route requests to instances which are healthy. And we'll take a look in a little bit to see how ELBs do that using a health check. Now, ELBs in AWS can implement a couple different algorithms, and we'll see that there are actually different types of ELBs available. So depending on the type of ELB you have provisioned, that ELB will use a particular type of algorithm. If the Elastic Load Balancer is handling TCP requests, then it will use a round-robin load balancing algorithm. On the other hand, if it is load balancing web requests, so these are HTTP and HTTPS requests, those requests are going to be handled by a least outstanding requests algorithm, which means that the load balancer will tend to route requests to the web server that's handling the least number of requests at any given time, which makes sense, right? A web server that's handling fewer requests is generally going to be less loaded than other web servers. So what are some of the benefits of an Elastic Load Balancer? We know what it can do. You sort of have an understanding of this load balancing pattern, but why would you want to use it? Well, it allows you to scale your application horizontally. We can spin up, let's say, 5 EC2 instances that are serving as web servers, and if we need to add more capacity to our platform, then we can continue to add additional EC2 instances. We can go from 5 instances to 7 instances to 10 instances and so on. And the Elastic Load Balancer can evenly distribute requests across our fleet of web servers, across our fleet of EC2 instances. The load balancer also can provide us with resiliency. If one or more of our EC2 instances were to fail, then the load balancer can detect that failure and automatically route requests to a web server which is available, which is responsive. That way, if we have web server failures, if we have infrastructure failure on our platform, that failure won't impact our customers. And then finally, generally when we deploy a resilient infrastructure architecture, we deploy EC2 instances across multiple availability zones. The idea is that if you were to lose an availability zone, then then customers would be unimpacted because their requests would be routed to the EC2 instances and infrastructure that lives in a viable availability zone. The load balancer is that component which is able to detect the failure of the availability zone, detect the failure of the instances in that AZ, and then route requests to instances in a currently available AZ. I mentioned that there are a couple different types of ELBs available. As of this recording, there are actually 3 different types. There is the application load balancer type, which is the one that we will use throughout this course. The application load balancer is primarily used for load balancing web-based applications. There's a network load balancer type. The network load balancer can load balance any type of network traffic. So if you needed to load balance, let's say databases, or just really anything, any sort of network application that's not running as a web application, then a network load balancer would be the most suitable type. And then the third type of load balancer is what we call the classic load balancer. And the classic load balancer was the original ELB type that AWS launched back in the day. And for a long time, it was the only type of load balancer which was available. It can do things that both the application load balancer and network load balancer can do. My guess is that at some point, Amazon is going to deprecate the classic load balancer, and you'll no longer be able to use them because the functionality has been replaced by application and network load balancers, both of which do a much better job at their specific type of traffic that they're load balancing. So when given a choice, you should generally always choose either an application or a network load balancer. When you're configuring an application load balancer, there are 3 components that you need to configure. And I'll generally summarize them here, and you'll be able to see me actually configure the application load balancer when we get to the hands-on segment of the lecture. The first component is what we call the listener. And the listener is something which you configure on the load balancer, and it basically describes what network protocol and port the load balancer is going to listen for traffic on. And when it receives traffic on that specified protocol and port, it will then forward that traffic to a group of EC2 instances, to a group of servers. That group of servers is what we call the target group. So that target group consists of a group of EC2 instances. And the EC2 instances are called the registered targets. And so anything which is a registered target is something that the Elastic Load Balancer can forward a request to, a request that is received by the listener. And then finally, the third component is the health check. And the health check is a periodic poll that the Elastic Load Balancer performs. It will poll each EC2 instance to determine the availability of the instance, of the registered target. Well, what does that mean? Well, basically, on a scheduled basis. It could be every 10 to 30 seconds. This is something we can configure. The elastic load balancer will try to communicate with a specific endpoint on that EC2 instance to check and see if the EC2 instance is responsive. If it tries to connect to that EC2 instance and the instance isn't responding, after a certain amount of time, the elastic load balancer will consider that instance to be unhealthy. So that registered target will then be unhealthy, and the elastic load balancer will no longer attempt to route requests to that particular instance. Here's a diagram showing how you can configure an elastic load balancer. We have the load balancer, and in this case we have not just one but two different listeners set up. So you can configure one or more listeners on an elastic load balancer, and the idea is that each listener can be associated with a different target group based on a rule that you configure for the listener. Now, in this course, I keep things pretty simple so that the load balancers you configure will generally only have one listener configured, and that one listener is pointing to a target group. But I just wanted to show you that it is possible to configure load balancers which are listening, have multiple listeners configured, and each listener has its own separate target group. Why would you want to do that? Well, you might have a platform which is sort of partitioned into multiple components. For example, you might have the static website components hosted at a different endpoint or path than some of the dynamic application website components. That's pretty typical. So if a customer is making a request for an image, that might be handled by one listener and go to a particular target group. But if the customer makes a request for something like an ordering page, then that might go to a completely different listener and target group. Amazon prices the ELBs on a per second basis, just like EC2 instances. And so one of the interesting things is that the ELB is a managed service, so you don't have to configure any compute infrastructure for it. And if you have EC2 instances running in multiple availability zones, then you can configure the elastic load balancer service to actually run in multiple availability zones as well. There are a couple additional features that I want you to be aware of with elastic load balancers. Now, these features aren't available on every type of ELB, but you'll come across these features with the application load balancer that we will work with. The first feature is what we call sticky sessions. And the idea behind a sticky session is that it allows you to essentially bind a user, bind a customer and the customer's requests to a specific EC2 instance. This is what we call this is something we call session affinity. And the idea is that normally if a customer is making a request and it's going through the load balancer will redirect that request to a different web server every single time. However, if you have sticky sessions enabled, then what will happen is a customer will send a request which is received by the load balancer. The load balancer then will send that request to a web server, and every subsequent request made by that same customer will then get routed to the same web server. That's what we call session affinity. Why would you want to do that? Well, there are certain applications, these are mainly legacy applications, which may maintain some state on the web server itself. In other words, when a customer is accessing the web server or the web application is storing some data on the web server locally. And that data might be something that the customer needs as they access the web application. That's in a modern sense, that's a bad practice. That's a really bad practice. We never want to maintain state on our web servers. We always want to store that state in something like an RDS database, which we'll talk about later in this lecture. However, there are still older legacy applications which may do that. And in order to support the hosting of those applications in EC2 and host them behind an elastic load balancer, you may need to enable sticky sessions. The next feature is SSL termination. And so SSL certificates are the component, the configuration component, which enables secure browsing. When you're using your web client to access something like a bank, you'll see that it's a secure session. It's a secure session because SSL has been enabled on that hosting service. Now, when you're setting up SSL, you could install a certificate on each web server, and that would be perfectly acceptable. What will happen is that the customer will connect to the web server, and using the SSL certificate, the traffic will be encrypted and decrypted by the web server. And that encryption and decryption of traffic can create a bit of compute overhead. And so another option is to install that SSL TLS certificate directly on the Elastic Load Balancer. And in that case, when a customer's browser makes a secure request, the secure request will be terminated at the Elastic Load Balancer. So the ELB will actually handle the encryption and decryption of the communications, and then pass the request on to the web server, sometimes in an unencrypted format. And the idea there, the benefit is that you can offload that encryption process from the web servers to the Elastic Load Balancer, where that might help you build a more performant service. And so finally, the Elastic Load Balancer, when I've been talking about ELBs from an architectural perspective, I've been talking about them as being an infrastructure component which sits between the customer and something like a public web server that the customer is accessing. That's really sort of an external facing Elastic Load Balancer. You can also use Elastic Load Balancers internally within your platform architecture, meaning that you might have one internal service within your architecture which needs to communicate with another service. And you could add a load balancing layer between those services. The load balancer then would never be accessed directly by customers. It would just be used internally to load balance the connections from between one service and another service. For example, you might want to load balance internal traffic to a database system, for example.